You've got that pile of reading, right? Articles, maybe some heavy research papers, and you need the key takeaways, like now.
Happens all the time. Maybe prepping for a big meeting or just trying to stay current. It can feel overwhelming.
Totally. And that's exactly what we do here on the deep dive. We sift through it all, pull out the crucial insights you need, and hopefully make it engaging.
Think of us as your shortcut. You point us to the topic, we guide you through the essentials, and today we're diving into something really interesting in the AI world.
Yeah, specifically large language models, or LLMs. We're looking at a method called MetaSynth.
Right, MetaSynth. It's designed to make these already powerful AI tools even smarter, especially for specific niche areas.
So if you're trying to get your head around the latest in AI training, or maybe just curious where this is all going, stick around, because MetaSynth tackles a problem that's, well, becoming a pretty big deal.
It really is, and that problem is data. You know, researchers like Villalobos pointed this out recently, and you just see it with models like Llama 3 using absolutely vast amounts of text.
We're sort of running out of human-written stuff to feed these huge models.
Potentially, yeah. Or at least high-quality, diverse human text is becoming a scarcer resource relative to the model's appetite. We need more fuel for these bigger AI rockets.
Okay, so the logical step seems to be get the AI to make its own training data, synthetic data. But doesn't that usually fall flat, like the AI just repeats itself?
That's historically been the major hurdle, a lack of diversity. If the synthetic data is just more of the same, it doesn't really help the model learn new things or get better in different ways. It's like trying to bake a better cake by just adding more flour.
Right, you need more than just flour.
Yeah.
So MetaSynth,
hmm
how does it cook up this smarter synthetic data? What's the secret sauce?
Well, the really interesting part is this meta prompting idea. Instead of just giving one AI a simple instruction, you have a bigger AI, they call it the meta LM, basically acting as a conductor.
A conductor.
Yeah. It orchestrates a whole team of other specialized expert AIs. They all collaborate to create the data.
Ah, so not just one AI trying to do everything,
Yeah.
but a team of AI specialists, like different experts.
Exactly like that. Think about solving a complex problem in, say, engineering. You'd bring together different specialists, right? People with different skills and viewpoints. That's the idea here. The Meta LM, they used Claude 3 Sonnet in this research, designed specific prompts for each expert agent.
Okay, interesting. And do these expert agents, like, talk to each other, collaborate directly?
No, actually, and that seems to be important. The Meta LM is the central coordinator. It keeps track of everything, gives out the tasks, and then puts the pieces together. Each expert agent only gets the info it needs for its specific job.
Huh. Like a project manager keeping different teams focused on their part without them all chatting constantly. Why do it that way?
It taps into this concept called fresh eyes. By limiting what each agent sees, they might come up with different angles, maybe spot errors, or suggest things the main coordinator hadn't thought of. It avoids groupthink, essentially.
Got it. So the Meta LM isn't just assigning tasks. It's actively using the separation to get sort of more creative or varied results. What else is key to MetaSynth?
Another big piece is what they call conditional instance generation. The Meta LM basically keeps a running tally of the data it's already generated. It categorizes it
Why do that?
to make sure the next piece of data is actually different. So before creating something new, it checks, are we just rehashing the same points with different words? They use specific agents for this, like a seed keyword expansion expert to find related but distinct terms, and a content analyst expert to judge the variety.
And how does that analyst compare things? Reading full documents sounds slow.
Right. It uses summaries. Another agent, a summarizer expert, creates concise summaries, and the analyst compares those. Much more efficient.
Okay, let's make this concrete. Say they want to generate, I don't know, a document about fintech. How would this whole team of AI agents work?
Yeah, the paper is a good example. It might start with the Meta LM asking a seed keyword extraction expert to pull key terms from some starting point, maybe blockchain, VC funding. Then it tells a domain expert, maybe an AI persona like a fintech entrepreneur, to write a draft using those keywords. That draft gets summarized.
Then what?
The Meta LM might then ask the same expert to write a second document, same keywords, but aiming for different content or style.
And how does it know if it is different enough?
That's where the content analyst compares the summaries. If they're too similar, it flags it. The MetaLM might then go back to the seed keyword expert and say, okay, give me some new related keywords.
Ah, expanding the topic slightly.
Exactly. And then it might bring in a different domain expert, like maybe a venture capitalist persona, to rewrite
Yeah.
the document from their perspective using those new keywords. They might even use a writing expert to vary the style. It keeps iterating like this until the MetaLM decides the new document adds enough unique value, and they have rules to stop it if it gets stuck or runs into errors.
Wow. Okay. That sounds way more involved, way more intelligent than just basic prompting. So the real win here is the diversity of the output.
That's the core contribution, absolutely. Boosting the diversity of that synthetic data. They compare it directly to standard template prompting.
Which often gives
That kind of generic, repetitive language, in today's fast-paced digital world, or leveraging synergistic opportunities. Stuff that sounds familiar because you've seen it a million times.
No. Yeah, the AI version of empty business speak. So MetaSynth avoids that because the MetaLM is constantly changing the prompts.
Precisely. It's dynamically creating prompts for the agents based on what's been produced and the need for variety, not just filling in blanks in a fixed template. This leads to much more varied text.
And they measured this diversity, right? It wasn't just a gut feeling.
Oh, yeah, very rigorously. They used 7 different automated metrics, things like task-to-vec diversity coefficient, which looks at meaning and structure, compression ratios, n-gram analysis to spot repeated phrases, and others.
So what did the numbers show? Did MetaSynth actually produce significantly more diverse data?
The results, especially in Figure 2 of their paper, are pretty compelling. MetaSynth's data diversity scores got remarkably close to huge real-world data sets like Common Crawl.
Wow.
And it blew template prompting out of the water across all the metrics for both finance and biomedicine, the 2 domains they tested.
Okay, that's a big difference. So you get this really diverse synthetic data. What can you do with it? Does it actually make other AI models better at finance or medicine?
This is the really exciting payoff. They took a pretty standard good model, Mistral 7B, and used just 25 million tokens of MetaSynth data.
Just 25 million. That sounds tiny compared to normal LLM training data.
It is relatively small, but by doing continued pre-training just on that MetaSynth data, they significantly improved Mistral's performance in those specific domains.
How significant?
Up to about 4% better in finance tasks and nearly 13.75% to be exact better in biomedicine tasks, which is pretty substantial. It shows that data quality and diversity can really move the needle.
That is impressive. And what if they'd used the boring template-generated data instead?
Performance actually went down.
Ouch. So the diversity really is crucial.
It seems to be. And maybe even more surprising, they found they didn't even need to mix the MetaSynth data with real-world data for this domain adaptation. The diverse synthetic data was effective enough on its own in their tests.
So you could potentially take a general AI, feed it this tailored synthetic data, and turn it into a pretty decent finance or medical specialist.
That's what these results suggest, yeah. It's a promising direction for creating specialized AI without needing massive, specialized real-world data sets.
Okay, but does that specialization come at a cost? If you make the AI a finance whiz, does it forget how to, answer general questions? Is there a trade-off?
That's always the worry, right? But they check that too. Table 2 in the paper shows that even when training only on the synthetic MetaSynth data, there was minimal negative impact on the model's performance on general knowledge benchmarks like MMLU.
So it got specialized without getting, dumber overall.
Pretty much, yeah. It seems to retain its general capabilities quite well.
Okay, so MetaSynth helps create better base data for adapting models. What about fine-tuning? Training a model for a very specific task, like analyzing sentiment in reviews. Does it help there?
It does, potentially. They developed a related method called MetaSynth Instruct. It uses the documents created by the main MetaSynth process as a starting point, and then uses the MetaLM again, this time, to generate and even evolve complex instructions for fine-tuning tasks.
Evolve instructions, how does that work?
They bring in more specialized agents, like a document transformation expert to rephrase things, a persona suggestion expert for different angles, a complexity expert to make tasks harder, and a question editor expert to polish the final instruction.
So it's trying to create really good, varied training examples for specific tasks.
Exactly, and it's different from methods that rely purely on human-written instructions or models fine-tuned on tons of real examples. They showed that fine-tuning a BERT model using data from MetaSynth Instruct led to better performance on tasks like sarcasm detection compared to using template-prompted instruction data.
Better, but still maybe not quite as good as using real human-labeled data.
Right. It didn't fully close the gap with real data, which isn't too surprising, but it was a definite improvement over the simpler synthetic approach. And the quality of the instruction response pairs generated looked pretty good based on their analysis. Models trained this way even held their own against Claude 3 Sonnet in some comparisons.
This all sounds incredibly powerful, creating diverse documents, evolving instructions, but having this conductor AI managing all these specialist AIs, that sounds computationally expensive, is it?
Yeah. That's definitely one of the main limitations they highlight. This whole iterative process, the meta LM coordinating everything, checking diversity, it costs a lot in terms of computation, specifically inference calls. They needed serious parallel processing, like 64 CPU threads to run their experiments efficiently. And even then, generating a single document took, on average, about 3.6 minutes on one CPU.
Whoa. Okay, that's not instant text generation.
Not at all. And they also mentioned the process wasn't perfectly stable. Sometimes the agent interactions didn't work out and they had to discard iterations. Plus, the documents they generated were relatively short, around 400 words.
Any other potential downsides, like biases?
That's another important point. Since it's all generated by an LLM, any biases present in that underlying model, like Claude 3 Sonnet in their case, could potentially be amplified or skewed in the synthetic data. They noticed, for example, an overrepresentation of terms like ESG, DeFi, and crypto in the finance data.
So you still need to be careful about what the AI is actually learning.
Absolutely. And they also note that more human evaluation of the data diversity would be valuable in future work.
Okay, so pulling it all together, MetaSynth looks like a really clever way to tackle the synthetic data diversity problem, making it possible to adapt LLMs effectively to specialized areas using surprisingly little data, and potentially even generating better fine-tuning instruction.
Exactly. That's the key takeaway.
But it's computationally demanding, maybe a bit unstable currently, has document length limits, and you need to watch out for inherited biases.
That's a fair summary. It's a very promising approach, suggesting that how intelligently you generate the data matters immensely, maybe even more than just raw quantity sometimes, especially for specialized tasks.
So for listeners, the upshot is this could be a pathway to more powerful specialized AI, even if you don't have Google-sized real-world data sets.
That's the potential, yeah. It offers a route to improve AI models more efficiently, targeting specific domains.
Which brings up a really interesting final thought. Could methods like MetaSynth actually democratize AI development? Let smaller players create really good domain-specific models. Or, conversely, are the current hurdles, the cost, the complexity still too high for that to be realistic anytime soon? What needs to happen to make this truly practical?
That's the million-dollar question, isn't it? There's huge potential for democratization if the efficiency and reliability improve. But right now, those practical challenges are significant. It's definitely something to watch.
A lot to think about there. If you want to really get into the nitty-gritty, the research paper itself, identifier 2504.12563V1, is the place to go, along with the related work they mentioned.
Absolutely. And our goal here was to give you the core insights from that kind of dense material. We'll definitely keep exploring cutting-edge research like this in future deep dives.
Thanks for joining us for this exploration of MetaSynth.